Hi, I'm Andy Parker-Bates from Festo. In this video, we'll take a look at 4 different ways in which we can make more advanced energy savings within our pneumatic system. The first one I want to look at is smart monitoring. There is an adage that says if you can't measure it, you can't control it. So with that in mind, the first thing I want to look at is how we can gain information from our system in terms of what's happening with our flow, our pressure and our consumption of compressed air. There are a number of different devices available to help us with that, from very simple flow and pressure controls through to more advanced systems. And these can be connected to our PLC system using things like IO-Link, analog, field bus technologies or industrial Ethernet. By gathering the information from our system, we can put those into higher order controls, which we can then use things such as artificial intelligence to monitor what's happening and to start predicting changes that we can make to improve our energy efficiency. In this instance, we've got our flow sensor, which can also measure pressure and consumption of the machine. And this is connected via, in this case, IO-Link to our PLC system. From there, that data can be exported into the cloud, where we can actually trend that over a period of time, and we can plot that on a graph for use in a visual dashboard, or we can export that information into something like an Excel file that we can actually save and we can do further analysis on. Once we've got smart monitoring, we're then able to look at smart control of our machines and our processes. This is an example of a simple machine. It includes vacuum control and a simple cylinder motion control. What we're going to do now is run this for approximately 10 cycles to get some insights from the machine in terms of the energy usage within the system. And from there we can start to look at what information we can see and how we can optimize the performance of the system. The data we captured during that machine cycle allows us to plot the traces at the various points across the cycle to see exactly how much flow we've used and what consumption of total compressed air usage we've had during the machine cycle. With the insights that we've gained from that data, we can take a look at how we can optimize the performance of the system and reduce our energy usage. In the first instance, we're going to reduce the pressure to 5 bar. We know from previous tests that this will have no impact on the speed of the cylinder or on the vacuum efficiency. To reduce the pressure to 5 bar, we're going to make use of a variable pressure regulator. In this case, you can see we're now at 5 bar, and we're going to rerun that test to see what impact that has on our flow and consumption data. With the data we collected that time, we can overlay it with the original run, and we can see that there's a reduction in consumption that equates to about a 14% energy saving. Taking our energy saving to the next level, I'm going to take a look at the vacuum. In this case, we've got an energy saving valve, which will reduce the amount of air that we're using in that vacuum function. Once the vacuum cup obtains suction, we can actually turn the air off, and it will maintain that suction without using any additional compressed air. So as before, we've combined that data with the earlier readings, and we can see that we've had an energy saving of a further 63%. If we combine that with the change we made earlier to the pressure, we've got an overall system saving of 68% in terms of energy usage. And that equates to a difference of 50 litres to 16 litres of consumption. So a massive saving can be made by making some very simple changes and using a little bit more smart control within our machines. Let's talk about weight and friction. It seems an obvious thing to say, but moving a larger mass requires more energy than moving a smaller mass. But how often do you think about that when you're designing your pneumatic systems? When looking at end-of-arm tooling and moving sections of machines, consider the materials that you're actually using. Rather than using metals, consider lightweight polymers as an alternative. Here's a good example of that using valve terminals. In this case, I've got a valve terminal made from a lightweight plastic polymer. Compare that to an older type of valve terminal that uses an aluminium subbase. This weighs significantly more, and when placed on the robot, actually removes some of the payload capability of the robot in the application that I'm using it for. Both valve terminals perform exactly the same function, but by reducing the size and the weight, it means we may get away with a smaller robot or moving axis, and we can also save cost and energy in the process. Similarly, when you're looking at your machine's electrical architecture, consider using lightweight I/O modules, because this will help reduce the wiring and again the weight, all of which helps us to save energy and downsize the overall size of our application. Friction is another issue that affects moving systems and can lead to extended product wear, or it can also lead to higher running costs. The use of things like flexible rod ends can actually compensate for some of that misalignment and allow us to improve the overall performance of the system. Where a cylinder is subjective to high forces or loads acting in multiple directions, then consider the use of a guided cylinder or even a mini slide where we've got better guidance systems that remove that friction and help to take some of that load out of the application. Selecting the right cylinder for these types of applications not only saves you energy, but also improves the performance of the machine and extends product lifetime, reducing the overall total cost of ownership for the machine's owner. That concludes this video on energy saving tips. If you want to take it to another level, then take a look at our predictive maintenance video, which will also give you more information about how this can be done automatically for you and provide greater returns on your investment. Don't forget to like and subscribe for more practical engineering guides.